Solving linear equations.
Is that it? Okay. Yeah. All right, we're doing 1-1 solving linear equations today for our first lesson. This is hopefully going to come easy to you because you have done this many times before, but trust me, we will delve deeper as we go. All right. Let me ask you this because I'm always surprised by this answer. If I give you an equation, and most of you in here should be able to solve a simple equation. Sometimes this pen, I have to keep hitting it, that's what I'm doing. Let's say 2x plus 3 equals 9. If I asked you to solve that for x, what would you do?
Subtract 3.
Why?
Because you have to get it equal.
Okay, so you're telling me subtract 3, and then you would do what?
Divide that 2.
Why don't you divide by 2 first and then subtract 3?
Because you have to subtract 3 first.
Why?
That's just how it is.
Why is that how it is? That's the rules. What rule? You have to get x by itself. How do you know the order in which to do it is what I'm getting at. Okay, but PEMDAS, multiplication, division come before addition, subtraction.
Dash come.
You're actually right, but it's not DAS PIM, it's SAD map. If you say it backwards. But it doesn't matter because multiplication and addition subtraction, addition, multiplication, division are equal. So we go, the point that I'm getting at,
Wait, what are you at?
Backwards PEMDAS. When we simplify, we use the order of operations, right? Yeah. And I'm going to go out on a limb and say y'all have never been taught to solve equations this way.
Like what?
To use the backwards order of operations.
No, I just did it.
You just did it.
Yeah.
Which is fine when you're in 1- and 2-step equations, but when you get into some really intricate equations, it gets hard to know the order that you do stuff in. So if you know in your head that there's a right and a wrong way to do it, and you can follow those steps, it makes life a lot easier. So now if I look and say, okay, do I have any addition subtraction that I can take care of? Yes, I've got this plus 3, so I can subtract 3 from both sides to get rid of it, right? Because we do the opposite. Am I going too fast with this? Am I assuming too much with these? Okay. I assume in honors that we remember how to solve 1- and 2-step equations.
Yeah.
And so now I can do the multiplication division because that's what comes next. And so because this is 2 times x, how would I get rid of it? Divide by 2. X equals 3. Which is my what? The variable, but what's it called? X equals 3 is it starts with an S, solution. This is my solution. How can I check to ensure that that solution is correct? Plug it back in. That's absolutely correct. All right, let's get into some slightly more, let's get into a little more complicated. I told you today would be easy, but don't let it fool you. I will say, just as a little disclaimer, before you do this, you want to simplify each side first. Simplify. I'm going to show you. So if you have multiple variables, simplify each side and make sure all variables are on the same side. And then you can do your SAD map too. Get your variable by itself. So I say we jump straight into the harder ones. And I skipped over expression and algebraic expression and terms and all that good stuff. You guys know what that vocabulary means? An equation has an equal sign, an expression does not. It's an algebraic expression. It has a variable in it. 2x plus 3 is an expression. 2x plus 3 equals 9 is an equation. Equations have equal signs. No, it's just terminology we'll use. Simplify the following expression and just that you know what an expression means. This we're focusing on solving linear equations here. All right, let's look at one. Look at one that's more on your level.
You know what I'm ready for?
What?
To make my music video.
How do you know about that already?
Do you want to work Connor will talk with my best friend, and I'll help him do it. Do you want to work together? Yeah.
Tell me what you think you do first here in order to solve for x.
You simplify.
Simplify, distribute, I heard several people say. That's absolutely right. So this becomes
3x minus 6.
so 3x minus 6. How about here?
6x minus 2.
Close.
Or plus 2.
Plus 2. So watch that sign, right?
Yeah.
All right, so I told you need to make sure all the variables are together and the sides are simplified before you start with your SAD map. So looking here, what can I do?
Add 6 and subtract 2.
What are these called? Why are they called like terms? They both have the x, right? If they have the same base and the same exponent, they're like terms, and you can combine the coefficients in front. So this becomes 53 equals, well, 3x and negative 6x gives me negative 3x minus 4. Now does it look like something you can SAD map your way out of? Yes. All right, so what do I do first? Add 4. Now what? Sorry. So x is negative 19. How might I check that? Plug it in, okay? Everybody always wants to distribute when you see parentheses, but that may not be the best option. I will tell you another little helpful hint. I'm glad that air came on because I was hot. Y'all good? Can I go to the next slide? Okay. Sometimes you'll encounter an equation that may look like, I'm going to make it a little bit harder in just a second. This. Okay? And I would encourage you not to distribute here. Why might you not distribute here? You can just divide it by 2. Here's your helpful hint for the day. If you ever see, and this will come in handy as we get into quadratics and polynomials and so much more. If you remember this, it'll really, really help you. This is basic, but we'll build on it. If you only see the variable one time, okay? Even if it's got stuff hooked to it, maybe it's got an exponent, maybe it's got a coefficient, maybe it's got parentheses, it doesn't matter. If you only see it written one time in the equation, you can always, always SAD map your way out of it. On this one, it's not. You'll be the sub, thank you. That's so nice. Sacrificial of you, oh my goodness. Okay, so if you see this, it's not wrong that you distribute. It's just good to get in the habit now, like you guys said, to go ahead and divide by 2. Parentheses are last, if you notice. So if I just ignore what's in the parentheses for right now and work outside in, x minus 5 is what? 6 plus 5 is 11. Does that make sense to everybody? Let's do some fractions. No. Mm-mm. Well, the reason we do that is because addition and subtraction are equal. Right. So it's whichever one. You've probably seen all over those memes that go around about which one is right. And they do.
Yes.
Yeah. They don't follow order of operations because these are actually equal. All right. Let's do. That's a 1. Whole big 1. Tell me what you know. Tell me what you can do.
Well, I'll start off with,
I would add 5. Why can you go ahead and jump into SAD map?
Because there's only one variable.
There's only one variable. Does everybody see it's only written one time? It's there once, that's it. So I can go ahead and sad map my way out of that. So parentheses comes last, so I'm going to work my way outside in. So add 5 to both sides. Okay, so I heard divide by a half. Does anybody want to do anything different? That's exactly what I would do. Anytime you start seeing a fraction, don't let fractions intimidate you. Okay, because fractions are our friends. We love fractions. Don't divide by a fraction, multiply by the flip, by the reciprocal. It'll make your life easier as you go. So all I do is I come here and I say, okay, well, I'm going to multiply by 2 over 1 on both sides. I have to do it to both since it's an equation. 2 times a half is 1, so that cancels. And it's exactly the same as dividing by a half. Does that make sense to everybody? Does it make dollars? Nothing. Crickets. Does it make so much sense that it makes dollars? Okay.
I was working. I got it wrong. I got it.
And of course, I can move the 3 and have, come on, x equals 9. Yay or nay? All right, let's evaluate, and then I'll actually be done for today. We should probably do 2 sections today.
Yeah, I think it. Because most classes right now are probably still introducing themselves.
You think?
Well, non-art classes. Yeah, can we just go and
Do y'all have your calculators?
Step equations. You take the exam like that. I forgot how to do with fractions.
We have a lot of fractions in here, so.
I forgot how to do.
All right. The good thing is, if you have your calculator, life is going to be so much sweeter because I'm going to show you how to do the fractions on your calculator.
I don't have a graphing calculator on. I have like a regular one.
What's a regular one? It'll still do it. Maybe not everything we would like for it to do right now.
I'll get a graphing calculator.
Yeah.
That's the one I have.
That should still convert over. You should have. Is my screen blinking?
Yes. It has a fraction button on it.
Yeah, it should still do it. Eventually, yes.
By when?
So I've got this problem in front of me. I have an equation, and then I'm asked to evaluate an expression. See the difference there? All right. So in order to evaluate the expression on the end, I need to find the value of g in the equation at the beginning, right? All right. So what do I need to do? So I'm going to solve this equation for g. All right. So everybody said subtract 5. Let me show you on your calculator how you can do it. And if you did it by hand, that's perfectly fine. All right. Anytime you do fractions on your calculator, you need to make sure they are in parentheses. Everybody always says, what's the fraction bar? Fraction just means it's being divided by. So this is 4 divided by 9. I'm going to close the parenthesis. And from that, I am going to subtract 5 and hit enter. Now, that is not a fraction, and if I start in a fraction, I need to end in a fraction. So here's the magic button. If you hit the button that says math, the very first option is for fraction. Hit enter, enter.
Yeah, I don't see that math button.
Whoa! Mine automatically goes to a fraction.
Yeah, mine went to
If
that.
you've got an Inspire, it will. And if you've got, yeah, that will.
What would I click on this thing?
That one has an option. It has an arrow that says F, arrow D, I think. Fraction to decimal or fraction to something like that. Did it give it to you? Was it a fraction or a decimal? Let me see. All right. So we all got on our calculators, and it's not that, I mean, I really, really, really want you to be able to do things by hand and in your head because it makes you a better problem solver. But when we're talking about time restraints on things like standardized tests and stuff like that, this is a good, quick trick to have to be able to get it back into a fraction. All right, so I've got 4g equals negative 41 over 9. And so the question was asked, could we just use this to plug in since this is already a 4g? And the answer is absolutely you could. So if I know that 4g is the same thing as negative 41 over 9, I need to now subtract 2 from that. So again, because this was already, instead of going through this one and finding out what g is and plugging it back in here, this was already in the form 4g. And I know that 4g is negative 41 over 9. All right, so now I need to subtract 2. And again, I want my answer as a fraction because however I start, that's how I want to end. Yeah, those calculators will. Math, enter, enter. So negative 59 over 9. Well, that's not what g is. That's what this expression equals.
But if I didn't realize that, like, what would I do? I feel like I wouldn't realize that.
If you didn't, so you can follow through solving this. You can divide by 4. And the same thing here. I'm going to think about this kind of opposite what I did with that fraction. Dividing by a fraction is the same thing as multiplying by a reciprocal. Dividing a fraction by something is the same thing as multiplying by the reciprocal of that something. Right? So I get g is negative 41 over 36. And then I would just plug this in for the g there. And I'd come back to the same answer. If it happens to be like that, that was just a fluke that it came out. Most of the time it's not going to be like that. Y'all want to do one more? Okay. Let's do this one. If 5y plus 2 equals 8 over 3, then what is 2y minus 6?
All right.
I'm going to give you all a second. So if I solve the first one, if I do 8/3 minus 2, so I have 8/3 minus 2. I'm going to put that as a fraction. That's 2/3. So 5y equals 2/3. So y would be, if I divide that by 5, I get 2 over 15. Multiply by 1/5, divide by, okay. So now I need to take this and plug in my expression. So 2 times 2 over 15 minus 6. 4 over 15 minus 6. 4 over 16. Nope, 15, right? What did I say? I'm losing my mind. Yeah, 4 over 15 minus 6. Ooh. Negative 86 over 15. Is that what y'all got? Nice. All right, so your homework. Oh, let me show you this one other thing. What if you're asked to solve for a variable that has another variable in there? For example, let's say I have the formula for the area of a trapezoid. Shout out to Ms. Wilson. Y'all remember it, right?
I don't remember any single thing. I literally don't remember every single thing.
What if I want to solve that for...
That's too much, though. That's like 3 to 4.
Solve it for B1.
B1. Oh, that's a 1.
B sub 1. First base. Solve it for this one. It's only in there one time, so I can still SAD map my way out of it. Just treat each variable the same way you would a number, and if it doesn't combine with anything, leave it written in there. So if these were numbers, what would you do first? What would you get rid of first?
The 1 to half.
The half, right? Instead of dividing by a half, I would want to multiply by 2. So I'd end up with 2a equals height times B1 plus B2. What can I do now? Divide by height, right? You don't want to start any type of simplification. You don't want to distribute that h through. You really just want to get rid of it since you're trying to get that solitary variable by itself. So I have 2a over h is equal to base 1 plus base 2. Now this should be easy. How do you get base 1 by itself? Subtract base 2. So I have 2a over h minus base 2 is equal to this one. Does that make sense to everybody? Hard? No, it's a little bit harder. There's one like that on your test, and everybody always misses that for some reason. Looks almost exactly like that. There's your hint. Yeah. Huh? I don't remember.
I just want someone to run this.
With what?
You know,
Yes,
I don't
yes,
wanna
yes.
fail, so.